Hey guys, so today we're going to talk about some probability and statistics. So to start with, I just want to tell you about some types of graphs. So as you can see here on your left, that is your basic line graph. The next one here in the middle would be a bar graph. And as you can see, it says, usually always says a title and says different on each axis what it is talking about and has a key. And then another one is a stem and leaf plot, which as you can see always comes with a key so that you know how to read it. Next I want to talk about mean, median, mode, and range. Mean is known as the average, which you just find the sum of a group and divide it by the number of data values. The median is the value in the middle of the set. Remember, median is like the middle, or like the median of a road is in the middle. So the mode is the value that occurs the most number of times in a set of data. So our mode is like most. And range is the difference between the greatest and smallest values of the data in the set. So I have some examples of this. So I've given you this data set of 12, 14, 7, 5, 1, 18, 4, 13, 12, and 6. So we said that the mean was the average. So to get that, I previously added all these together. So you add 12 plus 14 plus 7 plus 5 plus 1 plus 18 plus 4 plus 13 plus 12 plus 6. And then you divide that by 10 because there are 10 numbers in there, and you get 9.2. So all those numbers added together equal 92 and divided by 10, so 9.2. The median, the way that I do the median is the number set that I gave y'all is not in order, but I take them and I put them in order from least to greatest. So then I start by saying, okay, I can cancel the 1 and the 18, they cancel out together, the 4 and the 14, the 5 and the 13, the 6 and the 12, so I'm left with 7 and 12. Somewhere in between 7 and 12 is going to be the median. So the next thing you do is do 12 plus 7, so that gives you 19, and divide it by 2. We're going to find the average of those two, which will be the middle of those two. So 9.5 is the middle. Next is the mode, the number that occurs the most. As you can see, every number occurs only once except 12. It occurs twice. So mode is 12. The range is, like I said, the greatest minus the least. So our greatest number in the set is 18 and our least is 1. So our range is 17. The next thing I just want to go over a little bit is the normal curve. So through this normal curve, I want to discuss the empirical rule and standard deviations and what variance is. So as you can see with the normal curve, it is broken down into 34%, 13.5%, 2.35, and 0.15. So you'll often get a question on the praxis that says something about, like, if it's one standard deviation to the left of your median or average or anything in the middle, then what percentage is it? It's going to be 34%. So they can ask you if it is a standard deviation to the left or standard deviation to the right, and together that would be 68%. And also from the empirical rule, we can assume that 95% of the data comes between two standard deviations left or right of the average. And we get that by doing 13.5 plus 34 plus 34 plus 13.5. And that is equal to roughly 95. So also standard deviations, anytime that you get a probability problem on the praxis, that talking about the normal curve, it's going to say something about your average, which here is mu or 0, and then it's going to tell you your standard deviation may be 4, or your standard deviation in this case is 1. So that's going to be mu plus sigma. Sigma is your standard deviation. So here sigma is 1, and you just increase it by how many ever times away you are from the median. So another thing I want to talk about is variance, and variance is double the, sorry, not double, but you square the standard deviation to get your variance. Some questions sometimes ask for variance. So next is the central limit theorem. It also has to do with the normal curve. So no matter what the original distribution of a sample is, the distribution of the means to get closer and closer to a normal distribution as the sample size gets larger and larger. So basically what this is saying is that, say you have a sample size of maybe like 8 or 10, your curve may not be so normal. It may be skewed a little left, skewed a little right, but it's saying that the bigger population or the bigger data set that you can use off of, the more normal it's going to get. So therefore, they say that the central limit theorem is that if you have a set that is at least 30, then it's approximately normal. And the larger your number gets, the more normal it gets. So the next thing, I just want to discuss a little bit of probability. So the probability is each possible outcome has a specific likelihood that it will occur. So here you can see a simple probability table. This is just one I found online, but the main thing I wanted to point out that you often see on the praxis is to know that probabilities always equal 1. So for instance, in this, the table under the column where it says probability, you have to know that 0.03, 0.1, 0.15, 0.17, 0.25, 0.15, and 0.1 and 0.05 all equal 1. If it does not equal 1, then there is something wrong with your data. But they all have to equal 1, and that is a key concept to know for your praxis. And that's all for tonight. Thank you.